Hello good people, I'm going to talk about the atomic structure and subatomic particles. Recall that an atom of an element is the smallest unit that still retains the properties of that element. This does not mean that we cannot go beyond the atomic scale. In fact, atoms themselves are made up of subatomic particles. And just like we can think about atoms as spheres, we can also think about these subatomic particles as spheres as well. So what are these subatomic particles that make up the atom? Firstly, we have a proton, which I am representing as this red sphere. And let me write proton. The symbol for a proton is a lowercase p with a plus in the superscript. The next subatomic particle is a neutron, which I am representing with this yellow sphere. So this is a neutron. The symbol for a neutron is a lowercase n with a 0 in the superscript. And finally, we have an electron. I'm going to represent the electron with a blue sphere. Let me write that down as well. So we have an electron. And the symbol for the electron is a lowercase e with a minus in a superscript. Please note that these three particles have not been drawn to scale. The electron is much smaller than the neutron and the proton. The proton and the neutron are approximately of the same size and mass. More on that in a moment. So how do these three particles come together to form an atom? Well, there are two components. There is the nucleus, and let me bring one in, that is made up of neutrons and protons. So this raspberry-looking shape is a nucleus. Please note once again that this does not necessarily represent the reality. It is simply a way for us to think about the atoms. All right, so that takes care of the protons and the neutrons. They form the nucleus. Where are the electrons? The electrons will form an electron cloud around the nucleus. So we can represent it like this. So this blue shade represents the electron cloud that surrounds the nucleus. The electron cloud represents the volume of space where there is a high likelihood of actually finding an electron. Once more, this drawing is not to scale. If the nucleus was the size of a football placed at the center of a stadium, then the electrons would be something the size of a peanut running around the car park. This means that most of the atom is actually empty space. So as an early summary, I could say that this atom that I have circled in white is made up of a nucleus, which in turn is made up of neutrons and protons, and an electron cloud. And the electron cloud itself simply represents the volume of space where I am likely to find the electron. All right, let's explore some of the properties or characteristics of these three subatomic particles. Firstly, each subatomic particle has a charge. A proton is positive, so we would write +1. A neutron is neutral, so we write a 0. And electron is negative, so we write -1. Each particle also has a mass. And if I was to measure that mass in grams, I would find that the mass of a proton is 1.673 times 10 to the negative 24. So not much at all. A neutron is slightly heavier, and its mass is 1.675 times 10 to negative 24 grams. Finally, I have the mass of the electron. The electron is much smaller and also has a much smaller mass. It is about 9.109 times 10 to the negative 28. These numbers are a little bit cumbersome, so I could talk about the mass of these subatomic particles relative to an electron. This means that I'm going to give the electron a mass of 1. Compared to the electron, a proton is 1,837 times heavier. and a neutron is 1,839 times heavier than an electron. This means that when it comes to the mass of the actual atom, it is the protons and the neutrons that contribute the most mass. These two numbers are also a bit cumbersome. So when it comes to the atoms, we use the atomic mass unit. The atomic mass unit uses the proton as the reference. So I could say that the proton is 1.000 atomic mass units. The neutron is a little bit heavier. So the neutron is 1.009 atomic mass units. The electron is a lot lighter. It has less mass. So when it comes to the electrons, I could say that an electron has a mass of 0.0005 atomic mass units. For the sake of simplicity, we often round these values. So we will say that the proton has a mass of 1, the neutron has a mass of 1, and the electron has a mass of 0 atomic mass units. Note that the atomic mass unit is sometimes referred to as a Dalton, and it can be abbreviated to AMU or just U. Okay, now let's look at a couple of nuclei of some different elements. So I'm going to scroll down, and here are my nuclei. Note that we talk about a single nucleus, but many nuclei. So the word nuclei is the plural for nucleus. Okay, so the nucleus on the top left, so this one here, has a single proton. The next nucleus has 2 protons. The next one has 3, and so on. It is the number of protons that determines the identity of the atom. So if a nucleus has a single proton, then we are talking about an atom of hydrogen. If a nucleus has 2 protons, then we are talking about an atom of helium. A nucleus with 3 protons means that we are dealing with an atom of lithium. If the nucleus contains 4 protons, well, then I'm dealing with an atom of beryllium. If there are 5 protons, I'm looking at a boron. And if there are 6 protons in the nucleus, I'm looking at an atom of carbon. So once again, it is the number of protons that determines the identity of the atom. What about the number of neutrons? Well, in case of my atom of hydrogen, there are 0 neutrons. Helium has 2 neutrons. Lithium has 4 neutrons. Beryllium has 5 neutrons. Boron, as I have drawn it, also has 5 neutrons. And carbon has 6 neutrons. A couple of things to note here. The number of neutrons is not necessarily the same as the number of protons. And while the neutrons do not determine the identity of the atom, they do contribute to the overall mass of the atom. And we will talk more about that later. At this stage you might be wondering, well, what about the number of electrons? Well, that depends. If I'm talking about atoms in their ground or neutral state, the number of electrons will be the same as the number of protons. And so, for a neutral hydrogen atom with only 1 proton, I could say that it will also have 1 electron. A neutral atom of helium with 2 protons will have 2 electrons. A neutral atom of lithium with its 3 protons will have 3 electrons, and so on. In summary, an atom is made up of a nucleus and an electron cloud. The nucleus is made up of protons and neutrons. The number of protons will determine the identity of the atom. The number of neutrons and electrons may change, but in a neutral atom, the number of protons is the same as the number of electrons. We will explore this more in future videos. Finally, I would like to note that there is also a world beyond the subatomic. However, once we go beyond the subatomic, we step firmly into the field of physics. And that way, madness lies. That is all for now, and I will see you on the flip side.